let's get started. We are looking at related rates. So related rates are really, how do you find derivatives when all the variables that you see are actually functions of time? So this one here is an example where we're going to look at an expression, 4x squared plus 9y squared equals 1,000. If you're interested, that's actually an ellipse. But this ellipse isn't fixed. This ellipse is growing, changing through time. So x is a function of time and y is a function of time. And what you're going to be told in this particular question A, you're told the value of dy by dt, and it's a third. And you're being asked to find dx by dt. So in these related rate questions, you're always being asked to find dA by dt or dV by dt. You're always being asked to find some variable with respect to time, right? Some derivative of a variable with respect to time. And they give you enough information to put the package together. So what you would do in questions like this is you start off with the initial formula or expression in this case. And then you differentiate everybody. So it's very like implicit differentiation, right? So, but it's also like the chain rule. So it's a bit like a monster method. So here goes. If I differentiate 4x squared, I would normally just get 8x. But now I get 8x dx by dt. And the reason I get this guy is that I'm not going to differentiate 4x squared with respect to x. I'm going to differentiate 4x squared with respect to time. So you differentiate it with respect to x times dx by dt. It's a bit like 4 something squared get you 8 something times the derivative of the something. You see, it's kind of like the chain rule, isn't it? Right? So if you differentiate 4x squared with respect to time, you get the 8x and you get the dx by dt. And when you differentiate 9y squared with respect to t, you get 18y dy by dt. And when you differentiate a number, you get 0. So your first step in this process is to differentiate with respect to t. Now I can go the next stage 2 ways. I could simply just rearrange this equation to tell you what dy by dt is, and that will work. Or I could just plug in everything I know and find out what dy by dt is by solving a very simple equation. So I'm going to try it that way. I know it's 8 times 4 times dx by dt, because I've been asked to find that, plus 18 times 2 times dy by dt equals 0. So what I've done in this step here, do you see I've basically just replaced everything that they have told me its value for. So if you tell me x is 4, that becomes a 4. If you tell me y is 2, that became a 2. You're telling me dy by dt is a third, so that becomes a third. So what I now have is 32 dx by dt, 6, well, I believe that's 12 equals 0. And now I just solve for dx by dt. So I'm going to use my tried and trusted technique of as long as you do it to both sides, it's okay rule. So I'm going to subtract 12 from both sides. I'm then going to divide both sides by 32. I should be able to do that in my head. What do you get? You get, what's going to work? 4. So that's going to give me 3/8. And so we have found the rate at which the x coordinate is changing with time. So if the y coordinate increases at the rate of 1/3, I don't know, per second probably, and you look at what's happening at this particular point in time, the rate at which the x coordinate is changing is negative. So the x coordinate is actually in this shape is coming down. So if you took this ellipse and you just followed it through its journey, you would actually see this ellipse getting transformed. It would probably go from a big sausage this way. It would be coming in and the sausage would grow up the way. Can you imagine the ellipse just essentially changing through time? And so what you're kind of allowed or able to do with related rates is that you can now model things that change through time. So it's not a fixed thing. The circle gets bigger through time. The sphere gets larger or smaller through time, right? The square increases in size. Things change with time, then related rates is how you're going to tackle that issue. You happy about the differentiation in the plug and chug with a solve? We go. Okay, let's look at another one then. I'm sticking to homework question or like homework questions. So this one is like 5. We have an x squared plus a y squared plus a z squared equals 9. And this is what we've been told. We've been told that the dx by dt, the rate at which the x coordinate is changing with time, is 7 units a second. The rate at which the y coordinate is changing through time is 6. We're told the coordinates, in other words, we're told the value of x, y, and z, and they're doing it this way, I guess to save space, is 2, 2, 1. So if you think about that, that's just saying that we're being told that x is 2, that y is 2, and z is 1, right? And that's all the things we've been told, and we're being asked to find one missing guy. Find that guy. Okay, so I'm going to start with my original expression. Just out of curiosity, does anybody know what that shape is? What do you get if you take all the points which have the relationship that they're x squared plus their y squared plus their z squared is 9? What do you end up with? It's a 3D shape.
Is it a sphere?
It is. It's the skin of a sphere, the surface of a sphere. So you're starting with a balloon, right? The surface of a balloon. And this balloon is going to get distorted in some way. God, it could turn into a football for all I know, right? And the x's are going to get bigger that way, right? And the y's are going to get bigger this way. And I think the poor z's going to come shrinking downwards to make up for the changes. And so it probably will turn into a football. So let's do our step 1 then. If you differentiate x squared with respect to t, you get 2x dx by dt. And if you differentiate y squared with respect to t, you get 2y dy by dt. And if you do z squared, you get 2z dz by dt. And if you differentiate a number, you get 0. Have you noticed that in these questions, x, y, and z are treated exactly the same? That's different when you do implicit. When you do implicit, isn't x is treated a little bit differently than the y's? You know, an x cubed just gets you 3x squared, but a y cubed gets you 3y squared dy by dx, right? So when you think implicit, this isn't quite implicit, right? It's kind of more general kind, but has a kind of implicit feel to it as well. Right, so I'm just going to plug in everything I know. X is 2, dx by dt is 7. Y is 2, dy by dt is 6. Z is 1. And so we end up with that guy. And that's 28. That's 24. And that's 2. Okay, since I'm running short of room, if you add them together, you get 52. And if you subtract it from both sides, you get negative 52. And so dz by dt is half of that. So I was right. Isn't the z coordinate shrinking downwards? So if you imagine the x and y getting bigger and the z shrinking, wouldn't this sphere turn into more like a football, which is called an ellipsoid, if you want to know its real name? Are we good? Okay, this next one is not a homework question. This is one I'm just making up of my own, which is always dangerous. Oh, let's find out what it is. There we go. Here is just an ugly expression equals 3. You're told x is 1. You're told y is 0. You're also going to be told that dx by dt is 5. So that's what you're being told. And you're being asked to find dy by dt, right? So I just randomly put some stuff together just to show you that this technique doesn't need to be x squareds and y squareds, right? There are other possibilities, right? So if you want to differentiate each one of these with respect to time, you differentiate this guy, you will get 6x squared dx by dt. Okay, what will you get if you differentiate e to the power of y with respect to t?
E to the power of the y dy dt.
Yeah. And I don't know why, but sometimes the simple ones catch people. What do you get if you differentiate x with respect to t?
dx by dt.
Yeah, technically 1 dx by dt, but nobody writes 1, right? And you got 0. Now, I know x is 1, so what's that going to get me? 6 times 1 squared times dx by dt, which is 5, plus e to the 0 dy by dt, plus dx by dt, which is 5, equals 0. Are you all happy about the plug and chug part? And isn't the last bit just going to solve for the missing guy? In this case, find out what dy by dt is. So what's that going to be? This is 30. That's 1. And this is 5. So you add these together, you get 35. And so you can subtract it from both sides. And actually, I don't need to anymore because the way it worked out, our answer is that. So could you imagine I could give you any ugly expression I like with x's and y's in it? And as long as I tell you the x value and the y value, and one of the two, dx by dt, or the other one, the dy by dt, won't this process allow us to find who the other one is?
Yes, that's true, but please don't.
Why? It's fun. Some of the best things I've ever learned were from my mistakes. You learn much more from your mistakes than you do from, you know, just getting things right all the time. So that's going to be, yeah, I've learned a lot more from my mistakes than I ever have from getting things right. Okay, next question is we're now going into, oh, how would I describe it? Applications, I guess. Story problems. Now, there's a basic, this is a version of 6. And I'm just going to read out the thing. You can check your homework when you do it yourself. But I'm going to visually draw what the heck's going on. So that's the ground. I've just drawn the ground. There is a plane flying horizontally at an altitude of 1 mile. So, little dotted line, 1 mile. There's my aircraft. Am I an artist or what, right? Yeah, that looks like an aircraft, right? Now, what's happening to this aircraft is that it's flying horizontally, so it's traveling this way. Different color. Traveling in this direction. And it's traveling a speed of 460 miles an hour. Okay. And it passes over a radar station. Okay. There's my radar station. Okay. Find the rate at which the distance from the plane to the radar station is increasing when it's 4 miles away from the station. Oh, okay. So imagine it flew over it and it went by it, and we're imagining some point in the future, and the aircraft is now here. And so I'm going to set up some variables for things I don't know. Right now, this distance here is unknown. I'm going to call this distance x. And I don't know this distance. And I'm going to call that distance y. So I'm basically just putting labels on unknown lengths. Do you notice that what I've created here is a right angle triangle?
Excuse me, did you say that the X was 4 miles? Like you told us the X was 4 miles?
I don't recollect saying that. If I did, ignore me, because I didn't mean to say that.
So it's 1 mile high and then it went past 4 miles?
No, never
That's what you
mentioned
said.
4 miles. I don't recollect mentioning 4 miles.
Okay, I misunderstood.
Well, if I did, I'll try and edit it so I can take it out and pretend I never said it. But I don't recollect saying it. So no, all we know is it's 1 mile altitude and it's flying that way. The only 4 that you may have heard was 460 miles per hour. There's a 4 in it there. That might have been what you heard. So this distance is x, this distance is y, and the speed is 460. The speed is actually this direction, isn't it? So when you tell me the speed is 460, what you've actually told me is the rate at which x is changing with time is 460. So you've told me that. And we are being asked to find the rate at which the distance from the plane is station. Oh, guess what? I did say 4, because it's here. I didn't think I'd got to that part, but we're being asked to find this guy's rate. And we're being asked to find it when x is 4. So you were right. Good grief. Does anybody else remember me saying 4? Or was that just a... Oh, God, I'm glad. I'm going to have one of those little labels where I go like that and say, yeah, Donald, so I know who I am. Okay, I think I've got everything that I need until I look at my picture and I realize that I'm kind of missing something. First thing I'm missing is I need an equation, right? I need one of these things, right? So when I look at this, I say, there is a right angle triangle going on here. This is 1, this is x, and this is y. And so Pythagoras comes to mind. Would you agree? Now, according to Pythagoras, won't the hypotenuse squared be the square of the other 2 sides? And there is my formula. So I need a formula. In all these word puzzles that are going to happen today, that's going to probably be your first goal, to find the formula. Now, I'm going to differentiate with respect to t. So y squared becomes 2y dy by dt. The derivative of 1 is 0. I'm just putting it in for completeness sake. And this guy is dx by dt. That looks really good. And then, shouldn't I be doing plug and chug? And the plug and chug would be putting in dx by dt is 460, putting in x equals 4. But when I do that, I notice a glaring piece of missing information. See, I'll put little checks on it. Don't I know x? Don't I know this guy? I'm being asked to find this guy, but uh-oh, I don't know the value of y to use. So how am I going to find what the y value is? I know the x value is 4. But don't I also need to know a number for y? Now, in the earlier questions, you never had that problem because they just told you y was 7 or whatever it was and you'd use it. So we have to figure out how to get it. Any ideas how to get the value of y when x is 4?
Would you solve the Pythagorean formula, the first?
If I'm picking up right, you mean solve that?
Yeah.
Right. Can I just do that in my head and say it's the square root of 17? Right. Are you happy about how we found the y from the picture? We know x is 4 and we need to know what is y at the particular snapshot where x is 4, what's y going to be? Now, I put all those guys in and we are pretty much done now. So we have 2, the square root of 17 dy by dt, and it's going to equal 2 times 4 times 460. And then dy by dt then is this horrible mess. Yikes. 2, let's do it. 2 times 4 times 406. Oops. 2 times 4 times 460, which is that number, divided by 2 root 17, and 3680. Oh, I'm going to do a mistake here. I'm going to find the answer to this and write it down as a decimal, but I'm deliberately going to do a mistake. What did I do wrong? That is not the correct answer to this calculation.
You needed to put parenthesis before the 2.
Yeah. I don't know how many times I've forgotten to do that in the rush to do things. What do they want as accuracy anyway? They want to the nearest whole number, so 446 will do. So at that snapshot of time, as this aircraft is flying east, when it's 4 miles horizontal, this distance here, it's traveling away at the speed of 446 miles per hour. I guess the only people who would want to know that are people who want to shoot down that aircraft, because won't your missile now have to be faster than the speed of the aircraft, obviously, to catch it? Eventually, you would expect that, because you've got a longer distance to travel. Okay. Are we good with that first application question? Now, each application question is quite different from the next. So the next one we're going to tackle is like 17, like question 7. A street light is mounted at the top of a 15-foot pole. Okay, so here's the ground. Here is my light. And you've told me that's 15 feet. Okay. A man 6 feet tall walks away from the pole. And that man is 6 feet tall. And the man is walking away from the pole at a speed of d 5 feet per second. Okay. So if I call this x, then he has dx by dt is 5 feet per second. So it's a horizontal distance. So if you tell me speed, you're basically just telling me how the horizontal distance is changing through time. So it's 5 feet per second. How fast is the tip of the shadow moving? Okay. If you draw this guy and you just keep going, you get a guy here. And that distance is going to be y. And we're being asked to find the speed at which the tip of the shadow is moving. Some weird something there. And we're being asked to find that at what particular point in time? When he is 50 feet from the pole. Oh, so when you're telling me x is 50 feet. Okay. So I guess I should have probably stopped my x here, but that doesn't matter too much. Can you imagine that distance there? It's going to be my x. So I have a right angle triangle that looks something like this. I know this is 15. I know this is a right angle. I have a line here. I know this distance is x, and I know this big distance from here to here is y. And we are going to find this fella being told that that is 5 and that x is 50, right? So we got all the pieces of the puzzle. My first crucial job is I need to find some formula that connects the x and the y together. Now, your first temptation might be, oh, it's a right angle triangle, let's use Pythagoras again. And that's not really going to help much in this question. But I want to make this distance here green, just so it's more obvious that that's x. Pythagoras isn't going to help me find the connection between x and y, right? The connecting formula, right? Just doesn't help. Any ideas how I can, what I might use to do this? Oh, and I should have put in his height. So that line there is 6. Any ideas?
I'm a little confused about where you placed the little x, but my idea is that we could figure this out with ratios because the little
You
triangle
could.
is just
You could. You're on the right tracks.
Trigonometry.
Yeah. That might work, but that'd be messier. There's a quicker, kind of cleaner way of doing it. It's called similar triangles. Now, I think when Teresa was mentioning ratios, that's what I think she was thinking about, but maybe she was thinking about something else. If you imagine a very big triangle, the dimensions are 15 and y. And then if you look at this little baby triangle, this distance is y, this distance is x. Does it not make this side here y minus x? Can you see my two similar triangles now? The big one is 15 by y. The little one is this piece here. I know that distance is y. I know this piece is x, so that will be y minus x. Now, according to similar triangles, corresponding sides are in equal ratio. So we have 15 over 6 is equal to y over y minus x. And all I'm going to do to this expression, this formula that we've got, is make it a little bit easier to work with. So I'm going to cross multiply. Then I'm going to distribute the 15. And then I'm going to subtract 6y from both sides. And then I'm going to add 15x from both sides. Oops, it's a y. And then I'm going to divide both sides by 9. And that gets me my relationship. My relationship is very simple. The connection between the x and the y is that the y is 5/3 x. Okay, so back to remembering what our question is. Our question is, find the rate at which y is changing when x equals 50 and when dx by dt is 5. Okay, and the formula that I'm going to be working on is that guy. Okay. Differentiate with respect to t, you get dy by dt. What do you get if you
Can I ask a quick question?
Yes.
Sometimes I'm confused when you're going to write it dy over dx versus when I'm trying to find dy over dt. So can you mention how I can know that I'm doing dy? I'm trying to find dy over dx.
You are never going to find dy by dx in related rate questions. You're always going to be finding dy dx with respect to t. So if you know that you're in a related rate question, if you're doing a question where the variables are in terms of t, then you are never going to find dy by dx. So if the story is the rate of change of this is dx by dt is 10, you already know that you're in a related rate world. And if you're being asked to find dx by dt, so you're never going to find a dy by dx in any of these situations. So the way I would separate it out is, am I in a related rate question?
Okay, did you just write find dy dx up there on the top of your paper?
Yes, I did. It is.
So
Oh
you're saying,
God.
I'm
You
confused.
gotta remember, I'm growling at myself here. I make mistakes. You are never going to find dy by dx. Even
Okay,
if I
thanks.
accidentally write it down, you're still not going to write, you're still not
Okay.
going to. Yeah, so I'm not surprised you're confused. I don't know why I wrote that. I'm getting old. Right, back to our guy. We've got our guy, differentiate with respect to t. What does the 5/3 x get you when you differentiate it with respect to t?
5/3 dx by dt.
Yeah. And now we can plug in the numbers. Well, dy by dt is 5/3 times 5, and the answer is 25/3. And you might say, well, what about the x equals 50? We never used it. You're quite right, we never did. In fact, in this story, it doesn't actually matter, does it? Wouldn't the same answer be correct at x equals 40 and at 2000? Which means if you've ever been really young, have you ever tried to catch your shadow? Isn't it always in front of you? So you could keep running till you die, you'll never catch it. That's a depressing thought, but I guess that's what this is telling us, right? Your shadow's just going to be that little bit further ahead of you at any given point in
I
time.
have a little story about my daughter, my youngest daughter, Brittany. I was so sad, I wanted to cry, but she was afraid of her shadow at one point when she found it all of a sudden. And she was screaming and running around trying to get away from it. And I was so sad. I was like, it's okay. But she was just afraid of it. It's so weird. I've never had that happen before. I just couldn't believe it. It was something new in my mind that, oh, you're afraid of your shadow. It was so.
Well, I think that phrase probably came about because your child is not the first child to end up getting scared by their shadow. Yeah. I think one of the fascinating things about kids is that everything virtually for them is a first. Right?
Yeah,
You
along
could-
those lines, I miss the movie magic when I was a kid before I learned physics and learned medical anatomy and realized that all these people would have died a long time ago because they talk too much through movies.
oh,
So yeah, that kid innocence movie magic is great. Miss it.
it is good. I'll share you a story. One of my nieces, Amy, she was watching me. I love pickles, so I was in Scotland, and the pickles in Scotland are big, and they are extremely strong. They make your eyes water, take the enamel off your teeth. They have to have them in glass jars. If you put them in metal, they would probably rust through them. Right? They're stuck. They're bad, but they are great. And I was eating this big pickle, and she was, first time for everything, and she was looking, and she wanted, and I was dumb enough to give her one. And I thought, oh God, this is not going to end well after I did it, but you're committed, and she wanted it. And so this is the first time she ever ate a pickle, and she bit right into it. And it's like eating a lemon. Her poor little face went weird colours, and the tears were running down her eyes, and her cheeks get sucked in. And I thought, well, that's it. She's never going to eat another pickle in her life. And when she finished it, she went, good. And she loves pickles to this day. So that first experience can very often be, and I mentioned this theory before, why some of you hate carrots. The first time you got carrots, it wasn't good. And then your brain says, me and carrots ain't happening, right? That could have went the other way. Couldn't it have been she just said, pickles, ugh, right? And never liked the pickle from that day onwards. So everybody, when you're in that child, it's the first time you do almost everything. So yeah, that innocence is so cool. All right, let's continue our story. I think we should have time to squeeze in. Do we have time to squeeze in one more? Yeah, okay, let's squeeze in this one. Question 8. In this one, V is the volume of a cone. Since you might not know this, the formula for a volume of a cone is 1/3 pi r squared h. Well, that's kind of helpful because we actually have the formula that we need. What else do we know about this formula, this thing? We're told that the radius is 4 meters, but we're going to turn 4 meters into 400 centimeters. And we're told that the height is 2 meters, but we're going to turn the height into 200 centimeters. And the reason for that is that the volume is in cubic centimeters. So they're doing that physicsy thing, units, units, units. Because if you use the 4 and the 2 in your formula instead of the 400 and the 200, you're going to be in trouble. And we know that water is leaking out of a tank at the rate of 8,500. So we know that the rate of change of the volume is going to be made up of C, an unknown number, take away 8,500. And the C is representing the fact that water is going in at an unknown rate C, a constant rate C, and it's leaking out at that 8,500. What else do I know about it? I'm being told that dH by dt is 200 centimeters per second. Okay, we got that. And we're told that H is equal to 200. Well, we know that. Okay, we're told that, we're told that, we're told that. And we are being asked, okay, to find C. Normally you're being asked to find dv by dt. And once we find dv by dt, can I just use this to figure out who C is? So it's like I just find that guy first and then we'll figure out who C is later. Well, everything looks really straightforward-ish, except that we kind of have a problem, and it's a pretty major problem. Do you notice that there's an R in here and radius is going to change? You know, as the water goes down, can you imagine the thing that looks like that? As the water goes down, doesn't the radius of the top change? I know what rate the height is changing, but what I don't know is the connection between the radius and the height. Okay, so we've got to figure out how we can work that particular one out. And they tell us that the radius, right up the top here, right? They tell us the diameter, at least at the top, is 400. Oh, down in space. Okay, guys, your time is valuable. I will try and keep this piece of paper and remind me we need to do this guy tomorrow. We'll kind of leave it hanging. Say hi and bye-bye. I have an